optimization video part 4. I will try to do as much as I can slowly this problem because they told me that was really fast in the previous videos. I'm sorry for that because I were running out of time. We have here a cone and we have a cylinder inside this cone, right? We have a cone of radius 3 centimeter, cylinder inside this cone. They have the same axis of the cone and the cylinder has x centimeter um, radius. And what is the height of this cone? It's PB, height of the cone, which is it's PA, sorry. PA is the height of the cone, which is 8 centimeter. All right. In part A, he wants me to find the volume in terms of x. Volume of the cylinder. Volume of cylinder is pi r squared times h. Simply, volume of cylinder is pi radius squared. And how much is the radius? The radius of the cylinder, we said that it's x centimeter, so it's x squared, and times h. H, height of the cylinder, is the distance from O to A. Distance from O to A. Centers of these two circles. All right, I need to know what is OA now. OA simply is equal to PA, all PA subtracted from it PO, right? So this will be equal x pi x squared multiplied with OA, which is PA minus PO. Okay, I don't have a problem with PA because PA is the height of the cone and it's given as 8 centimeter. So we can say it's pi x squared 8 minus PO. I still need to have what is PO. Taking triangles POS right at O and PAB right at A, two right angles, and the common angle between them, which is reflexive, making these two triangles similar. And what is the ratio of similarity? It's PO over PA equal PO over PA equal OS over AP. That's great. Why? Because PO, we need to have it. PA is 8, OS is 3, OS is X, right? It's the radius of cylinder, and AB is 3, which is the radius of the cone. So what is PO equals to? PO is equal 8 times X over 3. PO is 8 times X over 3. That's it, because this implies volume will be pi x squared into 8 minus 8x over 3. Let me take the 8 outside common. So volume will be equal to 8 pi x squared, right, into 1 minus x divided by 3. That's good. That's good. So what do we have here? We have the volume of the cone in terms of x. Now, in part B, he wants me to, part B, let me check, he wants me to find the maximum value of V as x varies. The maximum value of the volume as x varies. X could be any value. I need the maximum x I can have, or the maximum volume as x varies, right? In order to find this maximum volume of the cylinder, we have to make derivative of Vx, V in terms of x. So V prime of x, right? What is V of x? We just found it. Let's derive this this what we get in volume here, right? V equal 8 pi x squared 8 pi x squared into 1 minus x over, let me expand it first. Let me do the volume here. Okay, let me find the volume over here. It's 8 pi x squared times 1, 8 pi x squared minus 8 pi x squared times x over 3. It's 8 pi x cubed over 3. How to derive this formula? 8 pi x squared, it's 16 pi x, right? Minus 3 times 8, 24 divided by 3, it's 8 again, pi x squared. And to find the maximum volume, we need to take the derivative equals 0. And we can take 8 pi in common, 8 pi x in common. What left is 2 minus 2 minus x equals 0. So either taking this value equals 0 or taking this value equals 0. Taking this value equals 0, since x is a positive number. Why it should be positive number? Because we will have no cylinder, just a line, right? So that's why we try to take only the 2 minus x equal to 0, and that gives us x equal to 2. Okay? x equal to 2, this is the maximum value the volume can get by substituting instead of x in the volume equal 2. So it's v of 2. It's 8 pi 2 squared minus 8 pi 2 cubed divided by 3, which is equal 32 pi minus 64 pi over 3. We can 96 minus 64, 96 minus 64, right? It's 32, right? So the final answer is 32 pi over 3. This is the maximum value that the volume can get.